Hello children, happy to see you in yet another episode of lesson Carbon and its Compounds, which is Unit 11 in your 10th standard science textbook. So let us see what is in part 2 of this lesson. In the first episode, we have seen about the general properties of organic compounds and how to classify it. There were 3 methods of classification. I hope you understood all that. Today, we are going to see about what is homologous series. So, what is a homologous series? By definition, homologous series is a group or class of organic compounds which have the same general formula, they have similar chemical properties, and the successive members differ by a CH2 group. So, this is what we call as a homologous series. To understand it, let us take the example of the alkane homologous series. You can see the members, the first few members of the alkane series about which we have learnt in the previous episode. The first member of the alkane series is methane, whose formula is CH4. We know the general molecular formula for alkanes is CnH2n plus 2. So, substituting for the values of n, we get the various formulas which is seen on your screen. If you see here, the difference between the number of carbon and hydrogen atoms in the successive members is CH2. For example, if you take CH4 and C2H6, ethane contains 1 carbon atom more than methane and 2 hydrogen atoms more than methane. Therefore, the difference is CH2. Similarly, if you see the difference in carbon and hydrogen between ethane and propane, again it is CH2. And it follows likewise for the other members also. So, that is what we mean when we say that the homologous series, the members differ from each successive member by a CH2 group. So, this is not only for the alkane series, for all the homologous series, the members differ by a CH2 group in a successive manner. Let us see what are the characteristics of homologous series. Successive members differ by a CH2 group. The CH2 group is called as the methylene group. Now, what is the molecular mass of the CH2? Atomic mass of carbon is 12. There are 2 hydrogen atoms. So, 2 into 1 is equal to 2. The total mass is equal to 14. So, the members, when we say they differ by a CH2 group, the molecular mass of successive members will be differing by 14 AMU. AMU stands for atomic mass unit. All the members will contain same element and functional group. So, when you say it is an alcohol homologous series, all of them will be having the OH functional group. They are represented by a general molecular formula. So, all the members of a homologous series can be represented by a general molecular formula, and the formula of the individual compounds can be obtained by substituting the value of n. The members show regular gradation in physical properties with increase in molecular mass. So, physical properties will have a gradation. Chemical properties are similar. Since we have the same elements and the same functional groups, the chemical properties of the members of the homologous series will be similar, and they can be prepared by a common method. So, if we know the method of preparation of one member of the homologous series, we will know how to prepare the other members also. That is why we say they can be prepared by a common method. So, this is what we have to know about the homologous series. Let us next see about the nomenclature of organic compounds. What is the meaning of nomenclature? Nomenclature means the method by which names are given. So, how names are given for organic compounds? That is what we are going to see in the next topic. The organic compounds were named originally depending on the source from which they were obtained. For example, formic acid was called so because it was got by the distillation of red ants, and in Latin, formica means ants. Similarly, butyric acid was called so because it was got from butter which has gone bad or from rancid butter, and acetic acid was called so because it is present in vinegar, and acetum means vinegar in Latin. So, depending on the source from which they were obtained, the names were being given, and therefore it did not follow any order. But we know that organic compounds occupy a large number in the day-to-day life, and as more and more organic compounds are being discovered every day, we need to have a systematic method of giving names for organic compounds. And that is why we have what is called as the IUPAC nomenclature. IUPAC stands for the International Union of Pure and Applied Chemistry. So it is an organization which gives us a method for naming the organic compounds in a systematic way. We follow certain rules, and based on the structure of the organic compound, the names are given to it. So this IUPAC nomenclature is the method by which we are giving names for organic compounds in a systematic way. Now, what are the components of this IUPAC name? Every IUPAC name consists of three parts. It contains a prefix, a root word, and a suffix. When these three are combined together, we get the IUPAC name of the organic compound. So, the IUPAC name consists of a prefix, a root word, and a suffix. Let us see what each means. Now, what is a root word for the organic compound? It is based on the basic unit in the organic compound. What is the basic unit present in the carbon skeleton or the carbon pattern? That is how many number of carbon atoms are present in the parent compound. If you know the number of carbon atoms present in the parent compound, we get what we call as the root word. Now, root words are there on your screen for the carbon atoms numbering 1 to 10. If the organic compound contains one carbon atom, then the root word will be meth. If it contains two, it will be eth. 3 means prop. 4 carbon atoms means we say bute. 5 means pent. 6 hex. 7 hept. 8 oct. 9 non. And 10 dec. You can see from the number of carbon atom 5 onwards, it is got from Greek numerals. So when you see an organic compound for naming it, depending on the number of carbon atoms, this will be the root word for the organic compound. So it describes the basic unit in the carbon skeleton or carbon pattern. Let us see what is a prefix. The prefix will represent the substituents or the branch that is present in the parent chain. So after identifying how many carbon atoms are present in the organic compound, we have to see if there are any additional substituents or branches present. So to name them, we use what we call as a prefix. So what is a prefix? It is an atom or a group of atoms other than hydrogen which are attached to the carbon of the parent chain. So the atom or group of atoms other than hydrogen which are attached to the carbon of the basic unit or the parent chain is what we call as a prefix. Now the substituents which can be used, it can be EF. Then the prefix which we use is fluoro. If the substituent is Cl, we call it as chloro. If it is Br, we call it as bromo. And if it is I, iodo. If it is NH2, a group of atoms, we say amino, CH3, methyl. And if it is C2H5 or CH2CH3, we call it as ethyl. So these are the prefixes that we use while giving names. Let us now see what is a suffix. Suffix gives the end of the name. Suffix is divided into two parts. One is called primary suffix and the other secondary suffix. What does primary suffix tell? It tells about the nature of bonding between the carbon atoms. It comes directly after the root word, and it tells us or gives us an idea about the nature of the bond between the carbon atoms. For example, if a single bond is present between all the carbon atoms, then the primary suffix will be ANE. If a double bond is present, then it will be ENE. And if a triple bond is present, it will be YNE. So this is about the primary suffix. It tells us the nature of the bond between the carbon atoms. Now what is secondary suffix? Secondary suffix gives us an idea about the functional group. It describes the functional group. For example, you can see in the tabular column which is given, if it is an alcohol, the functional group is OH. And the suffix which we have to use for this is OL. So for alcohol, the suffix to be used is OL. If it is an aldehyde, what is the functional group? It is CHO, and the suffix to be used is AL. If it is a ketone, the functional group is CO, and the suffix is ONE. And if it is a carboxylic acid, the functional group is COOH, and the suffix to be used is OIC, acid. So you must have a knowledge of what are the words to be used for different primary suffix or for secondary suffix, and then we can name the organic compound. So we have seen what is the root word, what is the prefix, and what is suffix. So once we identify this, then we have to follow a set of rules for the naming of organic compounds. What are the rules to be followed? Firstly, you have to identify the continuous longest chain of carbon atoms to fix the parent name or the root word. So to get the root word correct, we must identify the continuous longest chain of carbon atoms in the organic compound. Secondly, we have to number the carbon atoms continuously. We can number continuously either from left to right or right to left. And when we give the numbers, we have to keep in mind that least numbers are assigned for carbon atoms which contain the functional group or which carry the substituents, or whether it is a double or triple bond. This is very important. When we give numbers to carbon atoms must be numbered continuously. It can be either left to right or right to left, but we have to keep in mind that the least numbers are given for the carbon atom which carries the functional group, the substituent, or the double or triple bonds. The numbers thus given are called as the locant numbers. Suppose in an organic compound we have both functional group and substituent, then for which will we give priority? The priority is always given for the functional group. So when functional group and substituent are present, the priority is given for the functional group. After identifying this, we have to write it. How will you write the locant number? The locant number should be followed by a dash and secondary suffix, or a dash and prefix, as the case may be, because we have to specify the location correctly. So the number should be followed by a dash. When primary and secondary suffix are joined, the terminal E of the primary suffix is removed. When primary and secondary suffix are joined, as in some cases you will see, the terminal E of the primary suffix is removed. So these are the rules for writing the IUPAC names of the organic compounds. But learning rules alone will not suffice. We have to know how to write the names of the organic compound. Let us see a few examples. You can see the first example which is given on your screen. You see that there are 5 carbon atoms. So CH3, CH2, 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 CH3. How many carbon atoms are there? There are 5 carbon atoms. Therefore, what will be the root word? The root word will be pent. Next, you have to see what is the nature of the bond. All are single bonds. Therefore, what will be the word for this? It will be ANE. All are single bonds. Therefore, you have to use ANE. And what will be the name of this organic compound? It will be pent plus ane, which is equal to pentane. So the name of this organic compound following IUPAC rules is pentane. Let us see another example. You can see this compound also contains 5 carbon atoms in a straight chain, and there is one CH3 in the branch. So when we number this compound, we have to be careful. We said we have to number continuously from one end to the other. So the option is ours, but we have to keep in mind that least numbers are given for the carbon atom carrying substituent or functional groups. Here the substituent is CH3, The carbon atom which carries the CH3 should get the least number. Therefore, the method of numbering is from left to right. So, the second carbon atom carries the CH3 group. So, substituent is CH3 and substituent is present on the second carbon atom. Next is we are going to see what is the nature of the bonding. The nature of bond is single bonds. So, when single bonds are present, the ending will be A and E. 5 carbon atoms are present, therefore it is pent. All are single bonds, therefore it is A and E. The substituent is CH3 and CH3 is called as methyl group. Methyl group is present on second carbon atom. So, when we write it as 2-methyl and 5 carbon atoms, so pent plus ane, and the name of this organic compound is 2-methyl pentane. I hope you are able to understand. So, step by step, one by one, we have to see each individual detail and we have to give the names. Let us see another example for naming. You can see a compound is given on your screen and you can find there are different number of carbon atoms when you number it in a different way. The first method of numbering is what is correct. You number in such a way that you get 7 carbon atoms in a straight chain. So, what we said, carbon atoms should be numbered from one end to the other. It can be left to right or right to left. So, here we are numbering from left to right in such a way that the total number of carbon atoms in the straight chain is 7. The second way of numbering, you can see we are numbering from left to right only, but the number of carbon atom is 6. So, the second way of numbering is wrong and the first way of numbering is correct. And you can also see here that the CH3 group is attached to the third carbon atom. The CH3 group is called as the methyl group. So, methyl group is attached to the third carbon atom. In the straight chain, how many carbon atoms do we have? We are having 7 carbon atoms. Therefore, we have to use the root word hept. Hept stands for 7 carbon atoms. So, in the parent chain, we are having 7 carbon atoms. What is the nature of bonding? All are single bonds. Therefore, the ending is A and E. Apart from this, we are having a substituent CH3, the methyl group, which is present on the third carbon atom. So, we have to specify the number to which the methyl group is attached. It is attached to the third carbon atom. Therefore, the name of the compound will be 3-methyl heptane. I hope you are able to follow what we are doing. So, numbering continuously from one end to the other and numbering in such a way we have the maximum number of carbon atoms in the straight chain. Let us see another example. Here you can see there are 5 carbon atoms and there is a single bond between 2 carbon atoms. So, we have to number this organic compound. How should you number? Numbering is from left to right or right to left. It should be from right to left, yes, because the double bond should be present between 2 carbon atoms which are getting the least number. So, 1 and 2, it is between these 2 carbon atoms the double bond is present. Total number of carbon atoms is 5. Therefore, it should be pent. What about the nature of the bonding? 1 double bond is present. Therefore, we have to give ENE. The suffix will be ENE. And what is the locant number for this double bond? It is present between 1 and 2. Therefore, the locant number will be 1. And what will be the suffix? It is 1-ene. And when you give the name pent 1-ene. So, 5 carbon atoms, 1 double bond is between first and second carbon. Therefore, the IUPAC name is pent-1-ene. Let us see another example with a functional group. You can see CH3, CH2, CH2, OH. So, here you have a functional group which is OH. Now, how will you number this carbon? Left to right or right to left? It should be from right to left, because the first carbon atom is carrying the functional group. Totally there are 3 carbon atoms and the first carbon atom carries the functional group OH. 3 carbon atoms, therefore the root word is prop. What about the carbon-carbon bonds? All are single bonds. Therefore, the primary suffix is ANE And secondary suffix gives us the functional group. Here the functional group is OH. And what is the ending for OH? It should be OL. It is present on the first carbon atom, therefore it should be O dash. The secondary suffix is 1 dash OL because the OH group is present on the first carbon atom. So it should be 1 dash OL. What will be the name of this compound completely? Prop plus ane plus 1 OL. Now why is the E given in red letters? Because when we are joining the primary and secondary suffix, the E of the primary suffix has to be removed. Therefore, the name of this compound will be propen dash 1 dash all. So prop plus ane, we remove the E because we are combining a primary suffix and a secondary suffix. Therefore, the E will be removed and the final name is given as propen dash 1 dash all. Let us see another example with another functional group. Here you see it is COOH. I think you can tell now what is COOH. Yes, it is carboxylic acid functional group. How many carbon atoms are present here? We have to count the number of carbon atom present in the functional group also when we are fixing the root word. There are 2 carbon atoms, therefore it is having the letter ETH. The primary suffix will be ANE because you have single bond between the 2 carbon atoms. Therefore, the primary suffix will be ANE. The root word is ETH. Now, it is having a functional group, carboxylic acid functional group, for which we have to use the secondary suffix OIC acid. And when we are having primary suffix and secondary suffix, what do we do when we are combining both? We have to remove the E of the primary suffix. So you can see ETH plus ANE plus OIC acid. After removing the E from ANE, and when you join these words together, you get ethanoic acid, which is the IUPAC name of this particular compound, CH3COOH. So we have seen compounds containing only carbon atoms, compounds containing double bond, compound containing functional groups. How to give IUPAC names for these organic compounds. They are simple examples. Try to understand it. It will definitely help you in the higher classes. Let us now see the IUPAC names of various classes of compounds. Here you can see in this table we have alcohols, aldehydes, ketones and carboxylic acids. Depending on number of carbon atoms, we have different compounds. Let us see it. Alcohol, the first member of the alcohol series is CH3OH. It is called methanol because you have one carbon atom, methane. So removing the last E, and when you add OL, it is methanol. Similarly, you have the carbon atom 2 for alcohols, ethanol. If it is having 3 carbon atoms, you say propanol. 4 means you say butanol. 5 means you say pentanol. Note, the final ending for these compounds is OL because you have the functional group alcohol. Remember, for alcohols, the final ending will be OL. Similarly, the next group is aldehyde group. Aldehydes should end with which ending? It should end with AL. So there is not lot of difference between OL and AL. When you write these names, you have to be very careful when you mention the last 2 letters. Aldehydes end with AL. The first member of the aldehyde series is HCHO. 1 carbon atom is present, therefore the root word will be methane. It is an aldehyde, therefore removing the E, you have to add a AL, methanal. So HCHO is methanal. Look at the next one, CH3CHO, 2 carbon atoms, aldehyde group, ethane, ethanal. Next one, 3 carbon atoms, an aldehyde group, propanal. Similarly, you have butanal and pentanal. So when you say butanal, but stands for 4 carbon atoms, Al stands for aldehyde. That is why you have 4 carbon atoms, and the functional group CHO is also included in numbering the basic carbon unit. That has to be kept in mind. Next is the ketone functional group. Now ketone, the simplest ketone should have at least 3 carbon atoms because it is a non-terminal functional group where you have the CO in the middle, and on both sides you should have a alkyl group. Here you have two methyl groups. The first member of the ketone series is CH3CO, CH3. 3 carbon atoms, propane, ketone, ending should be ONE. So striking off the E in propane, you get propanone. So CH3CO, CH3 is propanone. Similarly, you have 4 carbon atoms with the ketone group butanone, 5 carbon atoms with the CO, that is pentanone. Carboxylic acids, they are terminal functional group. Therefore, you can have 1 carbon atom. The first member of the carboxylic acid series is HCOOH. You have 1 carbon atom, methane. Carboxylic acid functional group, ending should be OIC acid. So, when you strike off the last E and when you put OIC, it is methanoic acid. Similarly, the next one contains 2 carbon atoms. It is ethanoic acid. And when you have 3 carbon atoms, we call it as propanoic acid. 4 means you say butanoic acid. And when there are 5 carbon atoms, we say it is pentanoic acid. So this is how you give IUPAC names for the various classes of compounds. I hope now you are able to understand how to give IUPAC names for the organic compounds. If you understand it, it is very easy and you can name any organic compound which is given to you. So after listening to all this about IUPAC nomenclature, let me see how you are able to give names for what is given here in Test Yourself. First one, CH3CHO. How will you give IUPAC for this? First, see how many carbon atoms are present. 2 carbon atoms. Therefore, it should be ETH. It is got from ethane, and functional group present is CHO. Therefore, it is ethanal. That is IUPAC name of this compound. The second one is CH3CH2 CO CH3. 4 carbon atoms. But. Ketone is present. So, butane. Strike off the last E, and for ketone, ending should be ONE. Therefore, the name is butanone. And Cl, CH2, 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 CH3. So, here you have to number the carbon atoms. Numbering should be from left to right. I hope you got it. It should be from left to right. Totally, how many carbon atoms are there? There are 4 carbon atoms. Nature of bonding, all single bonds. Therefore, it is a derivative of butane, in which the Cl is present on the first carbon atom. Therefore, the name of this compound is 1-chlorobutane. Chloro, substituent on first carbon atom. So, 1-chlorobutane. So, this is how you name this compound. I hope, children, you have understood how to name the organic compounds. And as we continue our lesson to learn about few organic compounds, I hope you get acquainted better with the method of naming, which will help you in your future. Thank you for your patient listening. Thank you.